Chapter 6, Section 2 is entitled Fractions, Decimals, and Percents. And what we're going to spend a lot of time working on in Chapter 6, Section 2 is more of those transitions, transitioning from fraction to decimal, decimal to percent, fraction to percent, percent to fraction, whatever mix we can come up with. That's really what we're going to spend time talking about in Chapter 6, Section 2. So let's go ahead and start off with number 1. In number 1, they're asking me to write 0.7 as a percentage. So I'm going to change 0.7, a decimal, into a percent. Well, you saw in the beginning of 6.1, I already gave you the directions on how to do that, and it's written there again at the top of the page, or the top of the instruction column. It says to move the decimal 2 times to the right and add a percent sign. Now, as you can see, we've crossed out some things here because the notes are spending a lot of time talking about changing it to a fraction and then changing the fraction once you get the denominator of 100. We don't need to spend time doing that. To change a decimal to a percent, you just move the decimal 2 times to the right and add a percent sign. So when I'm looking at 0.7 here, I'm going to jump that decimal twice to the right. Now that second jump there, as you can see that I have, is an empty jump. Well, you know better than now, anytime we have those empty jumps, they fill in with zeros. So that's going to make this change it to 70. And I add a percent sign, and I have 70%. So 0.7 must be the same as 70%. Number 2, they're asking me to write 5/8 as a percent. Now, you've actually got a few possibilities here. You can, if you want to, change the fraction so it ends up with having a denominator of 100. And once you do that, the top number is automatically your percentage. We've done equivalent fractions this year. We've done equivalent ratios this year. So you actually know how to do that. But what they're doing instead here is they're going to change this to a decimal and then change the decimal into a percentage, which is really just about the same amount of work. It might be an extra step in terms of what's actually written, but really it's going to be pretty simple either way. So what they're doing here is they're dividing to change this into a decimal. They're going to start off and they're going to do 5 divided by 8, because that's how we change a fraction into a decimal, is we divide the numerator divided by the denominator. So I'm going to do 5 divided by 8 there, and as you can see, that's 0.625. That's a great calculator question, perfectly acceptable. And now that you have that as a decimal, you're going to change the decimal to a percent. Well, as you just saw in example 1, to change a decimal to a percent, we jump the decimal 2 times to the right and add a percent sign. So I'm going to go 2 times to the right and add a percent sign, and I end up with 62.5%. So 5/8 is 62.5%. Here's number 3. In number 3, they're asking me to order 17%, 0.25, 3/4, 0.1, 4/5, and 20% from least to greatest. Now you're going to have questions like this in the homework tonight, although there's not going to be quite as many elements to it, but still the exact same thing. They're going to give you some things there and ask you to put them in order from least to greatest. So what you have to do here is put these all in the same form. That's really how this works. So you can write these all as decimals, all as percents, or all as fractions in order to compare them, so we can put them in order from least to greatest. Now the one that's generally going to be the least amount of work is what they're showing you here is decimal, because decimal is the intermediary step. Decimal, we can go from fraction to decimal in one step. We can go from percent to decimal in one step. If we were going from fraction to percent, though, all right, fraction to percent, we'd have to go through decimal most likely to get there, which is why they're not going to choose percent. That's actually 2 steps away from a fraction. They're not going to choose fraction because we can change everything to a fraction. That's not a big deal. But then to compare them, we'd have to do common denominators for everything. And of course, that could potentially be quite a bit of work depending on what they give you. So that's not the approach they're going to use either. They're going to write these all as decimals here. So the 2 things that are already decimals there, 0.25 and 0.1, that's really not much work at all. 17% we're going to take and get rid of the percent sign and move the decimal twice to the left. That's how I come up with 0.17. And 20%, I'm going to get rid of the percent sign and move the decimal twice to the left, 0.20. And I'll talk about why I wrote that as 0.20 in just a second. Now the fractions, remember for the fractions, to change those into decimals, we're going to divide. So I'm going to do 3 divided by 4 here, which is 0.75. And I'm going to do 4 divided by 5 here, and that's 0.80. And again, I'll talk about why I wrote that like that in just a second. Okay, so we have everything as a decimal now. Now, as you can see, the one thing that got left blank is 0.25, and there's a reason for that. 0.25 is kind of in an ideal setup here in that it's already a decimal, so I didn't have to change it, and it's also got everything to have, or it's got place values that goes out to the hundredths place is what I'm trying to say. 2 things after the decimal. As you can see, what I did then is, because of that setup, I wrote everything to have 2 places after the decimal. And that's why 0.1 got rewritten as 0.10, because I wanted it to have 2 things after the decimal. That's why 4/5 got written as 0.80 instead of 0.8, because I wanted this to have 2 after the decimal. This one, even though I don't need to write 0.20, it could just be 0.2, I still wrote it as 0.20. The reason I did that is to achieve balance, because once I've achieved balance, then it's just a matter of me putting what I have in order, and I can kind of forget the decimals. So if you're one of those people that's kind of freaked out by decimals or has a hard time when they're different, well, I made them all the same, and then it's a lot easier. Right? If we look at what we've got 17, 25, 75, 10, 80, and 20. Again, ignoring the decimals. Why? Because I balanced everything out, which is something you can do in the homework as well. Well, I know how to put those numbers in order. Right? 10 would go first, then 17, then 20, then 25, then 75, and then 80. And of course, we just throw the decimals back in because that's what they were in order. So now that I know what the decimals are in order, now I can put the original things in order. Right? 10 started off as 0.1, so it's the smallest thing. 17 goes next. That started off as 17%. 20 would be next on the list. It started off as 20%. 25 would be next on the list. It started off as 0.25. 75 would be next on the list. It started off as 3/4. And 80 would be last on the list. It started off as 4/5. So in order, we have 0.1, 17%, 20%, 0.25, 3/4, and 4/5. Let's take a look at number 4 here. Decide whether using pencil and paper, mental math, or a calculator is most useful when solving the following problem. Then solve. If 27 out of 50 people surveyed have the newspaper delivered to their home, what percent of these people have the newspaper delivered to their home? And then it says 27 out of 50. All right, so if we're talking about 27 out of 50, and we're supposed to change that into a percent, because after the comma there it's saying what percent of these people, that's how I know I'm changing it to a percent. Now I have to make a decision. Do I want to use pencil and paper to solve this, mental math, or a calculator? Well, believe it or not, we can use mental math here pretty easily. Let's remember what a percent is. A percent is a comparison to the number 100. If we look at that fraction we've got there, it says 27 out of 50. Well, I can make 50 into 100 pretty easily by simply multiplying by 2. And that's not too tough of a task for us. Right? Of course, if I'm changing the bottom number by multiplying it by 2, I do the same thing to the top. Multiply it by 2. So that's going to give me 54 over 100. Well, remember, once it's over 100, the top number is automatically your percentage. So that must be 54% of the people. Now, when would we use the other options there? All right. Well, let's say the mental math came into play there. That would be something perhaps that I could make into 100 kind of easily. Like, let's say it was 4. All right. Hopefully you know, but maybe you don't recognize that 4 times 25 would get me to 100. So I'd be multiplying by 25 there. Now, let's say the top number then was 3.2. Most of us don't know 3.2 times 25 right off the top of our head, but we could do it. And so that would be a place where you would use mental math. Now, let's say instead the fraction there had a bottom number that was 12. Well, 12 to 100, most of us have no idea what I'd multiply by 12 to get to 100. All right, we can get up to 96 pretty easily because 96 divided by 12 is 8. But to get to 100, that's really not that easy. So that would probably be the time then you would use a calculator to solve. All right, so let's go ahead and take a look at the check it out examples here. Number 1, we're writing 0.01 as a percent. Well, as you can see, as it says there, we're going to move that decimal 2 places to the right and add a percent sign. So when I go 2 to the right here, that's going to give me 1, add a percent sign on the end, and that's 1%. Number 2, we're writing 9/60ths as a percent. So I'm going to divide here. I'm going to do 9 divided by 60 here to solve my first step, because dividing a fraction will get me the decimal form, which is 0.15. And then I'm going to convert 0.15 into a percent by moving the decimal 2 places to the right and adding a percent sign, and that's going to get me 15%. Number 3, decide whether using pencil and paper mental math or a calculator is most useful when solving the problem, and then solve. And it says 18 out of 20, there's our fraction, 18 out of 20 dentists recommend a certain brand of toothpaste. What percent of these dentists recommend the toothpaste? Well, 18 out of 20 is my fraction. And again, if I can somehow make that bottom number into 100, the top number is automatically your percentage. Well, if I multiply by 5 here, top and bottom, that'll make the bottom number go to 100, which is ideal. And because multiplying by 5 made that go to 100, I have to do the same thing to the top. 18 times 5 is 90. So then I'm saying, since it's 90 out of 100, the percentage automatically being the top number, that must be 90%. Or in other words, 90% of the people recommend that brand of toothpaste.